Hey everyone, how's it going? My name is Daryl. Welcome back to this channel. This is a new Python for Finance series. In this series, I'm going to teach you how to create your own algo strategies. I will build different basic algorithmic trading bots, which follows along with different types of trading strategies that includes the moving average trading strategies, MACD trading strategies, RSI trading strategies, and Bollinger Bands trading strategies. I will focus on intraday short-term trading. So for each trading strategies, I will backtest it with 1 minute levels stock data for the past 2 years. If we assume for each of the years, there are around 250 trading days, it ends up the backtest will go through around 500 trading days. The objective of this exercise is not to recommend any stock for buy or sell, but is to provide you enough backgrounds and data that allows you to create your algorithmic trading bot and backtest with your target stock. So, happy trading! These pictures just show you what we will cover throughout this tutorial series. What is the expected outcome? And here you can see there are some buy and sell actions throughout the days, and we also have the list of the trading throughout the day and the daily profits and also the total profits since you deploy your trading strategies. And of course, we will also have some technical signal over these pictures, say for example, the MACD, the RSI, the moving average, and also the Bollinger Bands. But I'm not going to go through the details at this point because for this video, what I wanted to show you is to let you know how we can download the minutes data of the past 2 years. So first thing first, we're going to download the data. And there's a code. Without the data, you are just another person with an opinion. So in that case, let's download some data and then try to build this platform. There are two platforms that I try to use to download the historical minutes data. One is the Photoboo and the other is the Polygon. The reasons why I use the Photoboo is that because I use these platforms to trade my stock. So the first things that come into my mind is that whether I could possibly to use this Photoboo's API service and allow me to download the data and then integrate to my trading bots directly and then to trade my stock through the Python platform. And however, the problem is that the Photoboo does not support to download the historical data in the US market. So in that case, I just move to the polygons, which allows me to use their RESTful endpoints to download some historical data in the US stock market. The methods that we're going to use to download the data is through an API function. If you remember in my AWS API gateways, I mentioned that there are two ways for us to download the data from the servers. One is to use a GET request and the other one is use the POST request. And for the GET request, it means that we are not going to provide any data. We are not going to upload any data. And then we just send our request to the backend and then backend servers. And then the backend servers will serve us back based on our request. And for the POST request, it means that we will upload some data. And then the backend servers will serve us back based on our uploaded data. And of course, we are going to use these APIs endpoints to help us to download some data from the Polygon backend server. The functions that we are using is the Aggregate Box. So this allows us to get the candlestick for a stock over a given data range in custom times window size. If we go to these documents, the API stock API document under the Polygon, you can see this is the functions that we're using. That is the aggregate bar. The parameters that we need to input, that we need to provide, includes the stocks taker, the multiplier, the time spans. And so for example, if I just pick 1 as a multipliers, this is the 1 days of the data. This is the 1 minutes of the data. And then you also can provide the start and end date of the aggregate time window. And finally, of course, you can set the limit of the data that you would like to download. The maximum is 50,000. And once you set up this API, say, and you can just see the response object over here. That is an example. And of course, you can just copy these URLs and then make it over your Jupyter Notebook or any other Python platforms that allows you to make the request. And one key point that I would like to highlight here is that you need to get your free API key in order for you to use the Polygon's service. So go to sign up for the service. You will get your free API key. And let me also provide you the free service that they provide in terms of the stock and API. Here you can see that you will have the end of the day data. You can make 5 API calls per minute. You will have the 2 years historical data, and so and so. Everything is free. So just go make a registrations and then get your free API key. Once you have that free API key, now we are ready to construct an API request. You can go back to these aggregate box functions and then copy this, and just this will be something like this shown here. I just highlight the key parameters over here. So that includes the ticker's name, the multipliers, the time span, the start days, the end day, and then the limits, the number of data that you would like to download, and also the free API key under this free account. And what I wanted to do is to set these parameters as variables, so that will allow me to change it easily later on. So say for example, I would like to set the ticker's name just like the AAPL, the apple, and then the multipliers equals to 1, and the time spans equals to minutes, because what we are going to do is to download the 1 minute data, and then the start date, whatever dates at this point, and then the end date also whatever dates at this point. I will let you know what we need to do. And then the limit, I just set the maximum limit, that is the 50,000 data that I would like to download within an Excel file, within a CSV file. And here I also need to provide the API key. So I will just leave it blank over here. And finally, I will use these F strings to construct these requests. Now let's get back to this start and end date. Remember that we want to download the 2 years data. Let's say, for example, today is 2000, say February 28th, and then 2 years ago, right? That is 2020, 2 years ago. And because we only have 50,000 data points, in that case, it is like around 2 to 3 months data. So in that case, I will just add it to, like, say the end of the sometimes like the end of the April, to download the 50,000 data points. So otherwise, if you just say, for example, if you provide a longer range, it will just end up with 50,000 data points. But of course, you can just change it to whatever you want. But for my approach, I would just use around 2 to 3 months to download the data. And then after that, after I make the first API call, subsequently, I will add 2 to 3 months again, in order for me to download all of the data throughout the entire 2 years in the past. So if I switch it back to April, and then if I get my API key here, you will see that this is something like this, your URL request. So later on, you can simply to change the start and end dates to further download the data. Once you have the constructed API request in a URL, you can make an API call and then get the response and start downloading and storing the results in a CSV file. Just like what I mentioned before, we can use the request to make a post or GET request. Remember, this is we do not need to upload any data, so we just use the GET request. And after we get the results, we would like to just use the pandas functions to help us to download the results into it downloads and store results into a CSV format. So the first things that we wanted to do is to use the GET methods and provide the URL and get the JSON response, and everything will be stored in this data object. And once you download the data, get the response, this will be something like this. Here are the response. You will get the ticket's name, the query count, just like what I mentioned. You will download 50,000. The maximum is the 50,000 data points because I limit the months. So it ends up that you will just have around 35,000 data points. Of course, you can just extend the periods as well. And you will also get the results. Here are the results that we would like to store. You will have the volumes, for example, the volume, the weight volume, the open price, the close price, the high, low price. Everything right now is stored in a dictionary in this result cell. And what we would like to do is to pass these data result to a data frame. And once we have this data frame, we would like to just store everything into an Excel file, CSV file. But before that, I would like to let you know what I need to do before I store them into a CSV file. Here you can see that the time, this is a Unix millisecond timestamp. So the first things that we need to do is to change it back to the human readable data datetime objects. So we'll use a datetime objects functions to just convert this into a datetime object. So now you can see that once I use that functions, this is the PD to datetime, convert these Unix milliseconds, because this is the milliseconds, so I just make the unit as MX, and it will help me to convert back to a human readable date format. And now this data frame is ready to be saved in a CSV file. In that case, now we can use the two CSV files to save this data frame. I use the ticket names plus the start dates plus the CSV format without any headers as the parameters shown here. But that is just for my reference. Please feel free to change it to whatever you want. And now I just repeat what I've done in previous steps, and then download and store the 1 minute levels intraday stock data for the past 2 years. So remember, what you need to do is just to change the start and end dates in order for you to capture the entire data in the past 2 years. Now I have all these data. The first things that I would like to do here is to append all these data points and save them into a single CSV file as one of my checkpoints. However, if you go through the data that you have, you find that there are two formats. One is I name it as an old format, and the other is the new format. And let me show you what I did in order for me to append all these data and save them into a single CSV file. And here are the files, all the files that we have in the old format. And I also have one format that is a new format that saved the latest data. And let me show you what are the difference. And here is the Excel file with the old format, and here is the Excel file with the new format. Here you can see that there's two additional columns in between the transactions and the date. So in that case, what I did here is to simply removing these two additional columns. So in order for me to append these CSV file, there are a few libraries that I need to use. That includes the glue, which is to help me to grab the CSV file inside a folder. And this OS just allow me to provide the path, the correct path. And then the pandas, of course, just to allow me to download this CSV file in a pandas framework. What I wanted to do is to append all this data into a list. And in that case, I will just capture all these CSV file under the old format folder. Capture all these CSV files. So I put a start over here, all the CSV file, and then read all these CSV file one by one, and then append them into this append data list. And of course, once we have these append data lists, I can just use the concat functions to just convert them into a data frame. And I also want to give them a name so that later on I can append these new formats, these old format data and new formats data all together according to the column names. And let me show you the results. Now, all the data in this old format folder has been captured and downloaded in this final data frame. So all these CSV file are appended together in this final data frame, and you can see we have the volume, theta volumes, open, close, high loads, and so and so. All these columns, and the data start from 2020 up to 2021. These are the data in the old format. And then for the new format, we use similar methods. We just use the append data, and also just to capture the files that contains the data, capture all these CSV file, what I mean. And in that case, I will append everything into this append data new. And even though we only have one file over here, I still would like to use this method just in case I have some more new files later on. And again, once we have these leads, I would like to convert everything into the data frame. And remember that we need to drop the two columns because some of the data, let me show you, some of the data are empty over here, this IJ, so they will be an NaN. So I just use the drop NaN across these two columns, and then just return me this new data frame table. And now I have this new data frame table. I just rename them accordingly. And let me show you the new data frame. Here we go. You can see again, we have the volumes, wait volume, open, close, high load, and the last data point and the last column is date, which is exactly same as the columns that we have in the old format. So now we are ready to combine them together and save that in our checkpoint 1. Now I just concat these old formats and also the new formats into a final table. And then for this checkpoint, I just save into a checkpoint file and then use the latest date, the last date that we have in this data file as the checkpoint name, and finally everything saved into this CSV file. Now we have this checkpoint 1, and these are all the data that we have in the past 2 years. Everything's the raw data. At this point, we did nothing to these data points, but it allows me to further append latest data with this CSV file. So I call it a checkpoint 1 because everything here is a raw data. Now we can create the second checkpoint to serve the algo. Now let's read back the checkpoint 1 file, and then we name the data frame as data full. This is the data frame that we have. The first things that I would like to do is to convert this date into a datetime object. And then I will just drop a few columns, which I'm not going to use them. Just the wait volumes, the time stamp, the transactions, and also the date. With these datetime object columns, I also want to create a columns that contains the year, month, day, hours, and minutes that will allow me to filter out some data later on. Now everything will then assign it back to a data frame called a DF. So let's take a look on the data frame. My goal here is to set up the checkpoint 2 that will capture the data 30 minutes before the core trading sections, and then ends by the end of the core trading sections. But the first challenge that I have is that there are some data that we have in this Excel file, in this CSV file, that are in the non-core trading hour, and so we need to remove them. And the second challenge is that there's a daylight saving issues. It means that there's a 1 hour shift during the summer times and then and then there's a 1 hour shift in the winter times. So the trading hour a lot aligns with the summers and also winter periods. So we need to cater these two issues. And you can actually create a for loops to solve these two challenges. But in my case, I just do it manually. I do not waste times to figure out the logic. So in that case, the first things that I want to do is to only keep the data that is between 8 o'clock to 4 o'clock. In that case, that should cater all these data during the summer times and also the winter times. And also the start times is 30 minutes before the core trading sections. So that is 8 o'clock to 4 o'clock. And then during the summer times, we want to have the data from 8 o'clock to 3 p.m. And then during the winter times, we want to have the data from 9 o'clock to 4 p.m. But at this point, we just keep the largest range between between the summer and winter times. And because the daylight savings difference in 2020 and 2022, I also capture all these data for and assign them to each of the years. For each of the years, there will be 3 periods. The first 3 periods is from January to March, and during this period of the times, I would like to get the data from 9 o'clock to 4 p.m. And during the second period, that is our summer times, we would like to capture the data from 8 o'clock to 3 p.m. And then the third period, that is the November and December, and that is the remaining 2 months. The data that we would like to have is from 9 a.m. to 4 o'clock. So in that case, the first things that I would like to do is to identify which days start to have that daylight saving. And that means which date that's starting from 8 o'clock. And starting from 8 o'clock, that means this is during the summer times, right? So in that case, at 2020, the daylight saving starts at March 9th. So everything before these days will be in winter times. I do not need to change anything because it will start from 9 a.m. to 4 o'clock. And if I run the cell, this is the day starts the daylight saving. And then before that, you can see the starting hour is 9 o'clock, and then the end is the 4 p.m. And then the second periods that we would like to have is from March to November. That is the daylight saving days, that is the summer times. Remember that once we capture all data within this this data in the summertime, that is starting from the March and then up to the around the end of the October. And once we capture all these data according to this index column, and you can then remove the 4 o'clock periods or the 3 o'clock period, because all we want to have is to have the data from 8 a.m. to the 3 o'clock. In that case, I just remove all these data after 3 p.m. And now these are the results starting from 8 o'clock and then end by the 3 p.m. And finally, what I need to do is to just capture the remaining data, and starting from the end of this series and the end of this series and till the end of the years. So I just what I need to do is just to capture all these data at the last 2 months. And again, so you can see starting in the winter times from 9 o'clock to 4 p.m. And finally, what I need to do is to just stacking these three periods together, and then I will have the data frame for 2020. And here's all the data in 2020. And similarly, I do the same for 2021. 2021, and then this is the final one, and also do it for 2022. But because we are still in the winter time, so there's no data in the summer times at this point. So everything, we do not need to do anything with the data for 2022. And so in that case, if I run this cell, run this cell, run this cell, run this cell, I will have all the results for 2021, and then there's nothing in 2022 as what I mentioned before, because we are still in the winter time. So finally, what I wanted to do is to stack them together and save in our checkpoint tool. And again, I will just use the final trading days as the file name. And here you can see in this checkpoint, I have two files. One is to use to store all this raw data, and later on I can just continue to append the new data in these raw data files. And the other one is used for the algo trading. So I will just put this Jupyter notebook in the GitHub. So what you need to do is to simply change, let me show you, simply change the ticker names and the start dates and end dates to download the data that you need, of course with your own API key. And once you have the data on hand, these notebooks will just help you to transform your data into an algo ready format. Now the data are algo ready. We have the data starting from 2020, and then around February times, and then at the 2022 also around February times. In the next videos, we'll start to build the algorithmic trading bots, and later on we can test it with these 1 minute level stock data for the past 2 years. So see you in the next video. Bye bye.